Good morning students. Today we will discuss about the next section, that is fifth modulo B part. First part we studied about the regular falsi method and Newton-Raphson method. This is a second part. In this part we will study the finite differences. Before that we have to see the definition of interpolation and extrapolation. Interpolation means x, we have a equation y is equal to f of x. X is considered as an independent variable, y is considered as a dependent variable. Here x we have to consider as a x0, x1, x2, x3, so on. If we substitute that values in our y, these y terms become y0, y1, y2, y3, so on terms. Now, how to recognize the function is a interpolation. Means the given a range of the values, that is a x and y. X value they will give, y value they will give, that is x0, x1, x2, x3, y0, y1, y2, y3. In this range, in between x0 to x3, the value if they ask to find, that become a interpolation. After the x3 and y3, if they ask, that we call it as a extrapolation. Means 1, 2, 3, 4. Here 3, 5, 8, 9. If they ask like this is a x value, this is a y value. Here if they ask to find y of 2.5. Y of 2.5 means that is in between 1 to 4. Yes, that's why the given function is interpolation. If they ask to find y of 5.2, this is after the 4 will get a 5, that become a 5.2. Then we call it as a extrapolation. By using this definition, we have to see our next formulas, that is finite differences. In this finite differences, we have two formulas. Finite differences. Finite differences means we have a x and y terms they will give. By using this we have to create one table. After creating the table we have to apply two formulas, that we call it as a Newton's forward interpolation formula, Newton's backward interpolation formula. That is, I will write those two formulas here. First, Newton's forward interpolation formula. YR, finding the function y0 is the initial of y, delta y0 plus r minus 1 divided by 2 factorial delta square y0 plus r minus 1 r minus 2 divided by 3 factorial delta cube y0, so on. This is a Newton's forward interpolation formula. Yeah, here r we have to find x minus x0 divided by h, that is x is a finding value. They will ask to find that value, we have to consider as x. X0 means initial value. X0 is a initial value. H is a step length of x. Here we have to apply Newton forward interpolation formula and backward interpolation formula for equal intervals. Means equal equal intervals. Means the step size of each x must be a same. The h must be a same for all the x terms. Now, this delta y naught, delta square y naught, delta cube y naught, these are the leading rows of the finite difference table. Delta y naught, delta square y naught, delta cube y naught are leading rows of forward difference table. How to create that table I will explain later. Just you have to remember first the formula is Newton's forward interpolation formula. That is yr is equal to y naught. Y naught is the initial value of x naught, delta y naught, delta square y naught, delta cube y naught, so on. These are the leading rows of our forward difference table. And r is x minus x naught divided by h. X is a finding value, x naught is a initial value, h is a step length of x.